myself. Welcome back, whimsical inventors, creators, and designers. In today's cast of Living Like Logan, we will be exploring an invention for our favorite four-legged canine friends. Let's get to it. Last summer, I spent time at home with my parents. I worked construction, and when I wasn't at work, I was tinkering in our yard. My best friends and hardest working apprentices were my family's three German Shepherds. These dogs were so much fun to play with. They were trained to fetch and swim, yet they were filled with love and thoroughly enjoyed cuddling and playing video games in our times of rest. I decided one day that my furry friends deserved an invention, a new toy of sorts. With this said, I made my way to the drawing board. After considering what activities my dogs enjoyed the most, I settled on the game of fetch. German Shepherds are some of the fastest dogs in the world, and I constantly found myself being outperformed by these wonderful beasts. This led me to my problem statement and the basis for this whole presentation. I cannot repetitively throw a ball or a frisbee far enough to entertain three adult German Shepherds. I needed a tool. As I began the concept selection process, one of my main drives was to make something new and whimsical. I asked myself, how have we traditionally played fetch with dogs? Of course, you can throw the ball by hand. We've used lacrosse sticks or tennis rackets or any sort of athletic uh, object of propulsion to throw the ball further. These are overdone, and you can go to any local pet store and pick up any one of these devices. Of course, you have your large slingshots made for tennis balls or baseballs. And then there's the homemade remedy of air compressed cannons, or even, if you're wild enough, combustion cannons, providing almost a tennis ball gun to shoot tennis balls further. I wanted to do something new. I wanted to do something fun. Something that would not only be a dog toy, but would also be a great addition to a yard. After brainstorming for a while, I settled on an idea that could be created by anyone with access to basic tools. This could be your welder or your rivet gun or even a handheld drill. I wanted to create a tennis ball trebuchet. The first problem, and probably the largest problem I had in this whole assignment, I had no idea how a trebuchet worked. I quickly found that brute force was not the answer. I needed research. To begin my research, I needed to get the gist of how trebuchets work. I have compiled a small bundle of YouTube videos that seem to encapsulate the basics of trebuchet mechanics. Of course, the links will be in the description. For the first video, I relied on one of my favorite designers, Adam Savage from the Mythbusters. In this video titled "How to Build a Trebuchet," here on the leftmost picture on the slide, it was published by the Science Channel. Adam explains thoroughly the three main parts of a trebuchet and how they all function as a system. This video was great for a beginner knowledge of trebuchets and how they work. As you can see, there's really only three parts of a trebuchet. But of course, I needed more if I was going to design my own. This leads us to the second video, Weapons 101 Trebuchet, how they work, traction and counterweight trebuchets. This was published by Medieval Equipment on the channel Military History Visualized. This was great. This led to three core relationships that to take into account. The relationship between the swing arm and the fulcrum, the relationship between the weight and the counterweight, or the payload in this case, and the relationship between the sling and the swing arm. All of this math will be presented on the next slide. And then finally, the third video I looked at just gave me a bunch of history on trebuchets. It was published by Concerning Reality, and you can see it on the rightmost title card here on the slide. The other piece of information that I used was a journal published in 2013 by Donald B. Ciano. He went through all of the math on how to get maximum efficiency out of a trebuchet. This research article was labeled Trebuchet Mechanics, fittingly. This was pretty much the groundwork for my math, and I essentially took his equations and whatnot, plugged it into my own machine. Of course, changing the variables and whatnot. Here's the research outcomes. So first of all, the arm length ratio for the trebuchet is 1 to 3.75. This means that the swing arm on the trebuchet needs to be 3.75 times the length of the arm that your counterweight will be attached to. The release angle of the trebuchet needs to be somewhere around 45 degrees. Of course, this needs to be adjusted depending on the weight of what you're throwing and whatnot, but as a good general base, 45 degrees is how you will get the maximum distance out of your trebuchet. The sling length actually was interestingly equal to the moment arm, or if you can see my cursor here, the same length as this one right here. These need to be equal. And then from the weight to the counterweight ratio is 1 to 133. So in the example of using a baseball as my projectile, if I had a baseball in the sling, then to times the weight of a baseball by 133, I get about 17 pounds of counterweight. So after the research outcomes, of course, as a designer, we follow our research with inspired design. And it is at this point that I just created a few design criteria. First of all, I wanted my trebuchet to be portable. Secondly, I wanted my trebuchet to be able to be created at home, like I said, with a basic welder and simple shop tools. Third of all, I wanted my trebuchet design to be functional. Of course, if I did all of this and it didn't work, it wouldn't be worth it. I began to design my trebuchet out of 1060 carbon steel. You can easily find this at any hardware store, or a better option, the scrapyard. The steel is not only sturdy, it's cheap, and it's easily manipulated with welders and power tools. It's one of the softer steels, so it's not overdoing it. And of course, it can be easily treated to be more weather resistant. Starting with the base of my trebuchet, which you can see in the bottom right of the slide, I wanted to keep the footprint of the machine relatively small, but large enough to generate as much power as possible. Here you can see that the footprint of these welded rectangular base is only about 2 foot by 4 feet. The construction of the base of the trebuchet is primarily welded, and then we would add wheels and a hitch so it could be pulled by an ATV or a lawnmower, or even a bicycle if you needed to. The trebuchet frame stands at about 3 feet tall. While fully extended, the swing arm, which is this one in the middle here, would exceed about 5 feet. The frame will be bolted to the base, providing collapsibility if needed. This could be for storage or perhaps for cleaning. A threaded steel bar, which can be seen right here, will be placed betwixt the frame and swing arm, and this will provide a fulcrum for the swing arm. Nylon string will be tied to the swing arm, attaching the payload pouch to the system. The pouch should be made out of a sturdy leather or cloth. This could be found around the house, a canvas bag, perhaps an old leather satchel, or anything of that sort. On the other end of the swing arm, of course, you need a counterweight. This basket will be adaptable with the ability to be loaded with stone, sand, or other massive material. I wanted to make sure that this project was adaptable for any yard. So you could literally go to your driveway, pick up a couple pebbles, throw them in the base or the counterweight basket to adjust how far your trebuchet throws. Or the difference between a baseball and a tennis ball. A tennis ball is lighter, so you can go ahead and take some of those stones out to launch a tennis ball. Here you can see a couple of my prototypes. To help with the rust and weather resistance, the steel frame should be painted in your favorite weatherproofing paint, perhaps a fun color to complement your lawn. I love the idea of a red and white and blue, perhaps, trebuchet. to go for a 4th of July barbecue or bonfire. My go-to paint recommendation, of course, is Rust-Oleum. Tried and true, sticks to steel really nicely. As I said, here are a couple prototypes for the project. Every project deserves a good couple prototypes. This is my first one that I made. You can see here, it's just cardboard and a little bit of wood dowels. This was kind of a proof of concept for me, and it worked great. So I went ahead and I went pretty much with this design. Simple, cheap, but still works. You don't need to be reinventing the wheel. Here's my other prototype. This one in the industry they call a Lego type because you can see I made use of my favorite building brick, Legos. And this is essentially getting down with adaptability in all the right areas to make sure that I had all my numbers correct. Here's a couple of my CAD renderings of perhaps this might be what the final piece might look like. Of course, if you're building this at home, there's creative liberty and creative freedom. This basket is an interesting design. I kind of threw something together, and I think that this would be cool. And if you were going to go full scale with this, we could definitely make this injection or compression molded out of a sturdy plastic, such as PVC or high density polyethylene. To round out this idea pitch, I believe it is fair to include what coat or, or what cost would be to manufacture the design. My personal preference for hardware stores is, of course, the Home Depot. Thus, I will be specifying my bill of materials and costs from their store. Here's pretty much everything you would need on the screen right now. And you can see with the materials that I picked out, uh, it comes to a total of only about $120. That seems kind of steep, but this is if you were going to go to the store and buy everything from scrap. I paid for things like 8-inch wheels. You could pull those off of any red wagon that you have. Or a lot of this could be gotten from a scrapyard. Sheet metal, go ahead and you could probably find a whole bunch of that in the scrapyard. Around the garage, you might already have a bunch of hex bolts. I wanted to use materials that were available to people without breaking the bank. Well, in conclusion, this trebuchet was definitely a worthwhile and interesting project. Definitely one you could create for your own yard. Think of the quality time you can now spend with your furry friend while minimizing the physical toll and inadequacy of your ball throwing abilities. For only 120 or less, this project would be a great long-term investment, lasting for years. I implore everyone to find a hobby, especially during these unusual times of social distancing. I realize that this trebuchet is a bit goofy and it might be a hard sell, but it was fun to do this project. Of course, this speech on top of this project was an interesting challenge, but it was fun. I enjoyed myself. And if there's anything the world needs right now, it's a little bit of fun. With our families, our furry friends, and our imagination, we can do anything. Thank you for your time.